In this video, we're going to talk about scatter plots and what their correlations are. A scatter plot is just simply a graph that's got points plotted that show a relationship between two sets of data. And the correlation is simply the type of relationship that those two data sets have. First of all, you have a positive correlation where both data sets increase together. Or in other words, an increase in one results in an increase in another. So if you look at a graph, the points are all going to have an upward trend, all right? A strong positive correlation. You can see the points are all pretty close together, and they're definitely going increasing, all right? So as an increase in the x results in an increase in the y. All right. A weak correlation means that basically means that the points are a little bit scattered a little bit further apart. Okay. But you can see that it's still this trend. If I draw a circle around it, this trend is still going up. Okay. No correlation means that the one data set doesn't have any impact at all on the other correlation. In other words, the data points are just scattered all over the graph. All right, so you have some that are up here and over here. There are some others that are up here or down here. They're just scattered all over the place. So the one data set doesn't have any impact at all on the other data set. Okay, a negative correlation says that as one data set increases, the other data set decreases. Okay, so as one value goes up, the other value goes down. Usually, as the y goes up, okay, as the y goes up, the x value is low, and as the x goes up, the y value becomes low. And there again, you have a weak correlation and a strong correlation. The strong correlation, the points are close together, and the weak correlation, the points are scattered a little bit further apart. So let's do several examples here. Okay, so you can see here, it says describe the correlation in the scatter plot between the weight and the height of each member of a basketball team. Well, you can see that here, if somebody's 68 inches tall, he weighs 160 pounds. So as their height increases, their weight also increases. So that means that this is, and the points are pretty close together. So this is what I would say a strong positive correlation. Okay? That's a strong positive correlation. All right, this one, it says describe the correlation in this scatter plot. Well, you can see these points are just sort of scattered all over the place. So there is really no correlation. Okay, there's no correlation here between the x and the y values. This one here, okay, you can see that they're trending. The points, if I draw a trend line that goes about halfway between the two sets of points, that trend line goes down. So that is probably even though the points are a little bit scattered apart, but it would probably be a strong, and it's definitely a negative correlation. All right, strong negative. Okay, so here it says, what is the correlation between the number of hours spent studying for a test and the grade that is made for that test? So if we're looking at the hours, okay, if the number of hours that you spend studying increases, what do you think is going to happen with the grade? Well, hopefully that the more hours you spend studying, the higher your grade will be. So an increase in the number of hours spent studying results in an increase in your grade. So that would be a positive correlation. All right, that'd be a positive correlation. And we can't really tell whether it's a strong or a weak correlation, but you would tend to think it would be strong, but you can't tell because each class is going to be different. What's the correlation between time and the amount of water in a swimming pool that has a leak? Okay, so here, if we're talking about time, as time increases, the longer time it goes, what do you think is going to happen with the amount of water? Okay, the amount of water, the longer the time goes, the amount of water in the pool is going to decrease. So an increase in time results in a decrease in the amount of water. So this would be a negative correlation. All right? And what's the correlation between the speed of a car and the color of the car? Well, the color has nothing to do with how fast the car can go. So that would be what we would consider a negative correlation. Or not, oh, I messed up. Not a negative. That would be one that says there is no correlation between how fast the car can go and its color. All right, so that does it for that one. And make sure you've copied the notes down from that first page, and we'll talk to y'all later on.